Hi, everyone. My name is Beryl, and I work in last mile delivery. And I'm joined by my colleagues today, Josie, Principal Engineer in Robotics AI, Aaron, Principal Research Scientist, also in Robotics AI, and John, Senior Principal Engineer in Amazon Fulfillment Technology. So we're very much excited you're joining us today, and we're eager to share how our teams use science and engineering to deliver for our customers. We're going to discuss the ways our teams work to develop new solutions, keep up with consumer demand, and maintain a focus on sustainability, and even more. But first, let's begin with intros, and I'd love to just hear about all of your careers. And can you each briefly describe your background and what you're working on before you joined Amazon, and what you're working on now? And Josie, let's start with you.
Sure. I'm a principal engineer in Robotics AI. I lead a team to develop computer vision for robots in our fulfillment centers. Before Amazon, I have experience in both startups and big companies, and I was also a professor of electrical engineering at the University of Washington. In my free time, I'm really passionate about equity and STEM education, and I've taught 8th grade computer science to students at Rainier Scholars for the last 6 years.
Yeah, I'll go next. I'm Aaron. I'm a research scientist in the Robotics and AI org, and I focus on autonomous manipulation. So I specialize in gripper design and robotic grasp strategies. And I currently lead some prototyping efforts. So I spend a lot of time in the lab running experiments. And I'm trying to mature, new robotic capabilities to support our order fulfillment network. Before Amazon, I was at NASA's Jet Propulsion Lab for 10 years. And there I founded and led the Robotic Rapid Prototyping Lab and was a group supervisor for the Extreme Environment Robotics group. So good fun. John?
Yeah, thanks. So hello, I'm John. I'm a senior principal engineer in the Fulfillment Technology group. And unlike these other two, most of my professional career has been here at Amazon. I joined over 20 years ago now, back when Amazon was still just a scrappy internet startup, a bookstore on the World Wide Web. And anyway, fast forward to today. Currently, I'm leading a lot of the work that will help, in my mind at least, shift Amazon to a more scalable inventory and resource management and process execution model. A lot of the models that we use to run our operations and our fulfillment centers and the rest of the network. This is also that Amazon operations can continue scaling out our customer fulfillment for at least another decade or so, all while leveraging a lot of the new innovations that are happening in automation, data science, algorithms, and as well as just improving our human experience.
Well, thanks all. Pretty varied set of backgrounds and areas of expertise. So before we get started, I'm going to quickly share a little bit about myself as well. I've been with Amazon over 15 years, and I actually joined as an intern, as a software development engineer intern, and worked on a number of V1 products in devices, such as the first Kindle, before moving to last mile delivery several years ago. So today, my teams are working on a few areas, including Amazon Flex, pickup points and lockers, mapping and routing, and so on. Okay, so John, you mentioned that you're currently leading work so that Amazon operations can continue to scale customer fulfillment for another decade or two. How do you innovate to meet our customers' needs?
Yeah, so over the past few years, a lot of our focus has shifted from building kind of discrete standalone processes like picking and packing stuff to building systems that manage connected process flow, capable of optimizing and orchestrating work in large batches across a very large building of connected standard work processes. when we move to process control at that level, rather than like discrete standalone processes, we can really help our people work more efficiently with new types of robotics, and then also make better promises of what we can realistically get done for our customers and also our employees. This kind of production efficiency, systematized, like helps us keep up with the growth of the new promises that we want to make for our customers, and without simply like building new buildings everywhere that our customers are. So it helps us to scale. A few years ago, another example of innovation that I was thinking of is, we moved into the delivery space, which Beryl leads today. And we had this idea that we could build our own delivery applications. And if we did this, we might be able to connect those apps directly to our customers to enable them to own more of their own delivery experience. And although now this idea seems very simple, like this allowed us to start having our delivery providers take pictures of packages as they left them at our customer's doorstep. Not only did this help Amazon ensure that the package ended up at the right place, it gives our customers more visibility that their package was delivered to their house correctly. It basically improves the trust between our customers and Amazon, and also the delivery providers that we have working for us. Kind of related to that, another far-fetched idea at the time was that we could let our customers also connect these deliveries to smart connected devices like their car trunk, or even their garage door or their front door, by leveraging IoT, Internet of Things technology and connectivity. It's now possible for me to order an expensive camera and not have to worry about sitting on my front porch at all. Instead, I can see when it's being delivered in my garage. I know it'll be safe until I can go get my hands on it and take it and play with it myself. Parcel delivery has been around for decades, and it's fascinating to me that Amazon is now in a position where simple innovation and invention can radically change these experiences for our customers, and also their expectations going forward about how they might want items delivered to them in the future.
Yeah, and the garage and home delivery products were ones that solved a real customer problem, and they were great to work on. So increased consumer demand forces us to think outside the box and innovate. And we need to continually keep finding ways to meet this demand by automating and improving productivity of existing processes. We've had multiple examples in the grocery space as well, especially through the pandemic. So Josie and Aaron, what are some of the ways that robotics, AI, science, and engineering has helped improve the delivery experience for Amazon's customers? Josie, let's start with you.
Sure. It's just amazing how much technology is involved in shipping orders to customers. I think like the speed and accuracy with which we fulfill orders is due to decades of innovation. We developed a package picking robot that sorts packages to the correct outbound truck. And this allows the robots to get the right package to the right truck, which helps us provide consistent delivery for our customers and fewer errors. We also developed a computer vision solution that can identify when there's an incorrect item in an order. And this obviously reduces the number of mistakes that reach a customer. There's also several computer vision solutions we've created to keep our employees safe. One of them is Distance Assistant. It shows on a monitor when two people are standing closer than 6 feet apart. And we put this in high traffic areas of the fulfillment center so that people can see when they need to create more space between them. We open sourced this code, and people have used it all around the world, which is really cool to see.
Totally. Aaron, what about you?
Yeah, I would add a few things. Everyone has had that experience of receiving a small item in like a large box. Not only is that frustrating, but it's also, of course, expensive to ship the box. So we're working to improve how we group and pack multiple item orders into fewer boxes that take up less space. And that's actually like it's an NP hard computational problem. So it's a big challenge. Another thing I'd mention is all the ways that Amazon is enabling us to receive our orders. So we're inventing these new delivery locations, like John mentioned, your car, the lockers, also our physical stores like Whole Foods. You can also specify the day or time of your delivery, or you can choose this no rush option, which is a much greener choice, and you can often get like a digital credit if you select that.
I love the no rush greener delivery option. So how else are you using science to make Amazon delivery more sustainable, Aaron?
Yeah, there's a number of initiatives here to eliminate single-use packaging. So we have recyclable packages that use less material, but we also have package-less delivery. So one of those efforts that's already in production is called Ship in Own Container, and that's growing really fast. Diapers are a classic example at my house these days as well. So the item already comes in a sturdy box. Why would you put that box inside another box to ship? You can just ship the diapers. And so that's very popular. One of the things I'm personally been working on in my lab is defining thresholds for damage to these new package types. So I've designed some test equipment and processes that can standardize and evaluate our recyclable paper and recyclable plastic mailers, just to make sure that the order gets to our customer while also driving down our carbon footprint. And there's kind of another thing. So just as shipping a small item in a big box is wasteful, sending a large truck onto the highway with only a small load in it is similarly wasteful and similarly bad for business. So we're using machine learning methods to better plan the trucks so that they can transport more per trip. And this is an area where Amazon's scale really offers like great opportunity because the optimizations that are available to us at this larger scale are going to be way more impactful than they are for a smaller network of vehicles where the constraints might be a little bit greater.
I love how we're thinking about both at the package level and the bigger truck level. John, can we get an engineering perspective from you as well?
Yeah, sure. So a general theme that I'm actually very excited about is leveraging where we are today to build data and systems that can track inventory across our entire supply chain, all the way from the point where we order it from our suppliers, the manufacturers, down to how we process that flow of inventory all the way to our customer's doorstep. With this level of end-to-end visibility, we can build optimization and controls into our planning, scheduling, and execution systems that minimize the amount of stuff that flows in and also reduce the wasted movement and operations and activities and just all the work that goes into getting it all the way through and to our customers. We're now in a position where we can also use sensors to accurately image and physically measure all of these products, all the physical material products that we're fulfilling to our customers. As we build this kind of factual data set about all of our products, then we can better plan for how to pack them into boxes. As Aaron described, put the right thing in the right box or even no box at all when we see an opportunity there. And then also even just moving into shipping containers or trucks that can more efficiently move, again, trucks, planes, everything along our delivery routes as efficiently and as green as possible. So with better item data quality, eventually we should be able to build processes that can significantly reduce packaging material entirely without worrying about damaging the products and all of the stuff that historically have prevented us from just handing products directly to customers. This will reduce a lot of the material waste that we see today, as well as use less energy to move stuff, again, through the entire supply chain. To me, that's an awesome place for us to be.
Agreed. Thanks, John. So building the data sets and systems to track inventory across Amazon's entire supply chain can become complex pretty quickly. And so how do we account for the uncertainty and complexity inherent in a large system? Josie, let's start with you.
Yeah, you have to solve problems in a completely different way for it to scale to the volume and variety of items we sell at Amazon. And I personally find that challenge super fun. We dive in deep to understand how our fulfillment centers work, often working alongside the associates to get that understanding. Like John said, we collect a lot of data from everywhere along the fulfillment chain, and we really dive deep into understanding patterns and trends and anomalies. We create huge simulations that test the ideas at the building level or the multi-building scale. We also prototype our ideas and test them out in real fulfillment centers with real orders to understand where maybe we misjudged reality. We also think about risk and what experiments we can perform to reduce that risk early on. And we just design inherently flexible and adaptable systems that can learn and improve over time.
Yeah, I'll jump on that. So big systems, large systems at the scale are certainly, there's a lot of uncertainty and complexity. My answer after all the time I've been here is just embrace it. Right. While it's true that these large distributed systems get kind of hard to reason about, and our vision of perfection and even of the basic requirements of the system are change continuously, but it's not just because the system is big. This uncertainty is also coming from, frankly, the evolving nature of our business and our learnings about it. And the fact that we can offer new features over time, the more that we learn and the more that we build. So we can iterate and continue as we go. This shifts our thinking towards how to build technology more organically and iteratively, which frankly, as an engineer, is much more satisfying. I've spent over 20 years, again, like being surprised at like what happens next with the systems that I've built. I always think like, oh, I solved the problem, we got something out, it's excellent. But then, the next year is very surprising. And over time, I've begun to look forward to how much that we can learn and discover as we go. But from a systems design perspective, this does mean design for scalability, design for availability at the component level, at the system resiliency and recovery level, and also in the data models and the APIs. They have to be extensible so that we can evolve them. And that's just a crucial design requirement in all of these systems that we're building. Sometimes this extensibility is even more important than getting the initial business requirements correct. Like, it's okay to start with anything, build momentum, and after we've gotten started, then we have a path to evolve the system into something that is big, comprehensive, and ultimately impactful to the business.
Well, after 15 years here, I'm also surprised year over year. Same over here. Okay, so at the scale Amazon is growing, innovation continues to evolve too. So I'm curious, Erin, how do you approach risk versus reward when it comes to innovation and improving the delivery experience for customers?
Yeah, good question. So we have a saying at Amazon that it's day one. So even as we grow and diversify, we want to continue to take risks and continue to invent on behalf of our customers. But to manage that risk, we're often rolling out these new initiatives as prototypes that are limited in scope. And if it's working, we scale it up to the entire network quickly. And so we've become really good at doing that scaling. The good ideas, of course, come from everywhere and anywhere. In our org, we have a very inclusive planning process where employees of any level can contribute concepts, even if they're for another team's products or services. And if that idea gets a positive reception, we might write a prep doc. And so for these, we try and imagine, what would the press release say on the day we launch this new product? And then we think of this desired state and work backwards from it. And that really enhances and distinguishes the great ideas. It gets you to think about the risks and the benefits. You have so many examples in Amazon's history of true innovation. Even though we're a very large company now, And I think it's due to some of these processes. So, from Prime to Kindle to AWS and Alexa, you have current efforts like Kuiper and Prime Air and the Climate Pledge. We don't just have good intentions here. We have mechanisms in place that promote that risk taking and nurture these kinds of big disruptive innovations. And that's something I love, about working here, and I think really sets Amazon apart.
And what you said around inventing on behalf of the customer is really important. We take a customer first view and we work back from there. For example, we know for certain that customers want faster shipping speeds and they want specific delivery related problems to be solved. So once we identify those areas, we move ahead as you described. So Aaron, what's next for Robotics AI?
Well, we're kind of just at the beginning for machine learning and artificial intelligence. I think there's a bunch of places where we can improve the experience of our customer, as well as the safety and satisfaction of our employees. We see right now a lot of one-off use cases of these technologies where we write a lot of specific and tailored code for a narrow application. And I see a future state where these algorithms become, more readily available and more accessible, like through AWS, for example. At that point, I think it becomes just another tool in our toolbox, and you'll see adoption and innovation and comfort with those systems tick, upwards pretty sharply. As a customer of Amazon personally, I'm also super excited about the electric delivery vans. So looking forward to seeing those on the road.
Yeah, I love Aaron's points. It's really, we always think of it as just the beginning here at Amazon. We're just always constantly trying to find ways to get orders to customers faster with lower cost and higher quality while keeping our employees safe. It's just what we do every day. Amazon's, like John said, constantly changing and growing. And so we have to build with adaptability in mind and develop technologies that are flexible and can extend, like computer vision solutions that can learn to recognize the new products that show up at Amazon every day.
Well, that wraps up our session. And I want to give a huge thank you to Josie, Aaron, and John for joining me today. And a big thanks to everyone who tuned in. I hope you all found this helpful and that you learned a bit more about the innovation behind Amazon's delivery teams. And check out the Amazon Principal Engineering Community page to stay up to date with what the Principal Engineering community is up to, and the Amazon Science blog to learn about the latest research from our science community. Thanks, everyone.
Yeah, thanks, Beryl.